Good morning. I would like to welcome you all to the Agricultural Research Institute. And before starting, I would like to ask you to switch off your mobile phones. The lecturer today is Dr. Roni Cohen, and the subject of the lecture will be the grafted vegetables in Israel, current status and future challenges. Dr. Cohen was born in Tel Aviv, Israel. He acquired his PhD in plant pathology from Hebrew University of Jerusalem on 1986. On 1987, Dr. Cohen was employed as a researcher by the Agricultural Research Organization of Israel, where on 1999 he was assigned as the Deputy Director of Neve Yar Research Center. On 2011, he became President of the Israeli Phytopathological Society. His main research interest concerns the management of soil-borne diseases and pests for poor pits, where he published a number of publications.
Yes. Okay, thank you very much. I'm very glad to be here today in your nice institute, and I would like to talk about the grafted vegetables in Israel. You said correctly, I didn't put it because I know that in Cyprus you practice it for a long time and much before Israel, and in a minute I will talk about the reason why we started relatively late compared to other countries. Well, as you know, grafted is an old technology used for many years in trees and roses, and for example, most of all the fruit trees, citrus, here you have pecan, roses are grafted, but grafting for vegetables is not so common. It's more complicated because you have to graft millions of annual plants, and it's already done. But if I'm telling to my friends that are not in the agricultural research that I'm working on grafted plants, they can't believe that millions of transplants are being grafted each year in the nurseries. But you know, okay. So the main problem for introducing this technology to the Western world, because it was made for many years in the Far East, is this methyl bromide. We used it in Israel, and we use it very extensively, mainly because the methyl bromide, Israel was the kind of the international laboratory for methyl bromide usage, because the factory for one of the biggest, if not the biggest factory in the world, was in Israel in the Dead Sea work, and the agricultural department of this company had very good relations with the research community and farmers, and we use it very extensively. But you can understand that to take this heavy metal balloons to other countries is very expensive. So maybe in other places like nearby, here your country, and even Greece. So you started maybe earlier than us. So the technologies are different technology, different method of grafting. This is the grafted plants. Here you can see the site of the grafting. This is only one method. You'll see there is different methods. This is the grafting site. And this is the ways that they do it in the Far East. For many years we know that, and we look in the literature, there are some robots and machines to do it, but as far as I know, there is no machine that is working perfectly, and the problem is not with the machine, is with the plant. That, excuse me, that if you have, let's say in the nursery, few days of cloudiness and cold temperature, so the plant will be small. If you have high temperature, the plant will be big and it will be not suitable for machine. As I was told, machines are working, if they are working in tomato grafting, but with cucurbits, I believe that in most of the world, they are still doing it by hand. Going back to the method, which is just want to show it briefly, there is different method, and this is, by the way, taken from a review that was written by Lee and Uda, one of the two scientists, one from Korea and from Japan, that started with the research in the Far East many years ago. And this is one kind of the robot. There's another one, and if you look very carefully, they are not very happy with the machine. There are two people working why it's not working correctly. So, again, the machines are, there are several machines, but no one is working successfully. For the extent of the grafting in the world, you can see. Don't look at the numbers. Look at the percentages. Let's say for the watermelon, I think that we agree all over the world that watermelon is the most common crop that is being grafted. Cucumber, you see the difference between Japan and Korea, for example, quite close, but what is very interesting is the melons. In Korea, 94%, in Japan, 23%. So I asked the people from Lee and Uda, I wrote an email and asked why is the difference? So the difference is because the type of the melon, the type of the rootstocks, if you grow it in a greenhouse, if you grow it in the open field. So we know in Israel that we have the technology for melons, but melons are more complicated compared to watermelons. You have more diversity, more cultivars, more precise needs of the market, and this difference can show you the difference and the problematic with grafting melons. So this is myself. This is Dr. Benny Aloni, who is one of our colleagues working on physiology and compatibility, and you'll see part of his works. And this was in the first international meeting of vegetable grafting held in Viterbo, Italy, in last October. And this is Professor Lee, and he was invited. He's the guru of the grafting, and he was a distinguished guest of the we took a picture with him. For the extent of grafting in Israel, so for tomatoes it's about 20%, eggplant very limited, watermelon, as I said, I was afraid to write 100%, but it's about 100% of watermelon. For melon, it's increasing, but for example, we have a disease in the Arava that we know, the monosporascus, that we can solve it with grafting, but we can solve it very effectively with chemical control. So we now use more the chemical control, but we're still learning it for the times that maybe chemical control will not work or will be limited, because you know that somebody can say that we don't want this chemical anymore, and by signing a paper, he will complete it. So we have to prepare an alternative. And cucumber, it's still in the research level. We are working on it, but mainly we don't use grafting because first we have chemical solution for other diseases. But again, we have to be ready for the day that chemical will be not allowed anymore, and because for cucumber growing, the transplant of the grafted cucumber is still expensive. So I will try to cover diseases, physiological problems, and then first of all diseases. We can graft cucurbits or interspecific, melon on cucurbita. We can do watermelon on cucurbita. We are trying to graft melon on melon, and it can work for certain diseases that we have resistant, like if we have fusarium wilt, we can graft susceptible melon or resistant one, but this is mainly on the research level. But the most common is cucurbita, and we are trying to develop some watermelon rootstock, and I will give a few slides about it. Now this is tomatoes. We'll talk about it. Fusarium wilt of melon. Here you can see the fusarium wilt in the northern Israel. There is a place that we know that we have a lot of fusarium wilt, and this is a susceptible ones grafted on squash cultivar. Here you can see the difference between a melon on a melon grafted on cucurbita, that you know the growth is kind of limited, and here you have some wilt. It doesn't protect completely, and here you can see melon on resistant melon. But I have to emphasize that this field was infested, and this is the disease of the non-grafted. But this is very, very unique because in this soil we have mostly fusarium wilt. But even in this place we start to find combination of diseases. We have fusarium wilt and macrophomina, and in this case this combination will not work. So this combination on melon, susceptible melon, on resistant melon can work only if we have the fusarium wilt. Here again, we can see the yield. The yield of the non-grafted is almost zero. The yield of melon grafted on the TZ, on squash, it's okay. But you have the higher yield, it's on melon. But this is the interesting that the blue one is melon rootstock from Charente type, on which the scion is ananas type. And here you have the green one is ananas type. It's the brother of the scion, but very near isogenic lines. So you can see that there is compatibility, even difference in compatibility, even in the melons. If you have melons from Charente type and you grafted ananas type, the yield in this case was lower significantly from the two ananas type that are brothers. So compatibility can be even inside melons. So watermelon, you can see fusarium wilt of watermelon, again in Farmanda, in the northern Israel, northern valleys, the non-grafted and the grafted. New disease that occurs in cucumber and in melons, it's crown rot. Fusarium Grisporum spatialis radicis cucumberino in cucumber. Here you can see non-grafted and grafted. The same was taken in the Araba by Dr. Pimonia. The same disease in melons. Can attack melons, and again, you see the typical symptoms of this Fusarium Grisporum, which is not a wilt disease, it's a crown rot disease. So watermelon, again, above 90%. We are grafting regular big watermelon. We are grafting mini watermelon. We are studying the agro-technology and fruit quality. So this is the picture why we are grafting. The non-grafted watermelons are susceptible to lack of new land. If you grow melons year after year, or maybe 2 or 3 or 5 years after melon, you can after watermelon you can get some kind of very poor growth. It's not really disease, but the plants are not happy. So maybe it's increase of pathogen in the soil, or we don't know exactly. Anyway, when you graft it or when you treat the soil with methyl bromide, you can overcome this problem, but grafting would do it very well. And this is the main reason that we are grafting. We don't know exactly if we have one particular disease or several diseases, but this is the phenomenon. So this we grafting, but in grafted plants, in certain cases, in certain combination, we face problems of quality. We have this white, if you cut it for the length and in another direction, you can see this white flesh, irregular growth, and the fruit maturation problem. And this problem, we don't know exactly why it happened. It can happen and cannot happen. Depends on growing condition. It depends on compatibility. But it's very important to know what is why it happens, and we know to measure it, to know what is the difference in firmness, in sugars, in quality. But we have to know, I think, why it happened and how can we avoid it. And just 5 minutes ago, I find two persons that are working on the same problem, and I hope to make more collaboration with them to learn from each other.
Only what percentage of fruit shows this symptoms?
It depends. In certain areas and in certain combination, you get zero. In other combination, in other area, you have most of it. So it depends on things that we don't know exactly why it happens. It is very important to know why it happened, in which combination. Very experienced growers, like we have somebody in Kalia area. He says that one of the reasons is the way of fertilizing. He said it's maybe one more too much nitrogen, too much another thing. So this things that we have to go back to the farmers and know exactly how they grow and look for this problem. The problem is much bigger with mini watermelon. This is a really mini watermelon. As I talked to this guys from here, which I don't remember the names, but very nice to know that they are dealing in the same problem as well. This is the ecstasy, mini watermelon, very small one, and we took this one as a model because this deformation that happens when you graft on squash, it happens all the time. If you take bigger watermelon or little bit or midi watermelon, which is between 2.5, 3 kilo to 5, it can happen, but the severity is lower. But if you take ecstasy, the mini one, and you graft it on squash, you get most of the time this deformation. But if you grow it on another or non-grafted or on another squash, you will get normal one. But if you taste the heart of it, you still get the feeling that you are eating an apple, not a watermelon. It's less kind. It's hard. Here it's very hard and non mature, and here it's mature, good taste, but it's still very firm. So the question, why it's happening? So we came to the idea to look for watermelon rootstock, to graft watermelon on watermelon, and to avoid this problem. This came from, I tell you to my mostly for the Israeli colleagues, in the Jewish religion you cannot mix two types from the religion laws, two types of vegetables, because it's called kil'aim. So it came from the Ministry of Science. Now the scientist here is professor in the Technion, and he's very religious man. So he want us, he had a call for research to deal with problems in agriculture that related to religion, to religion. My colleague is a religion teacher, so I told him, nothing, let's go. So we were funded, and we said, okay, we will develop a watermelon rootstock, and then it went on to the chief scientist grant. Anyway, And then now we came back to the phytopathological aspect, because if you graft on watermelon, you don't have resistances. So in our division, we have large germplasm. We said, let's look for important resistances, and then if you have, you can make a breeding program to create only resistance. You don't care about the quality because you graft watermelon on watermelon. So again, the ecstasy, grafted, not grafted. See the size. See, it's become bigger when you graft it on squash and deformated. But if you take midi one, you still have it, but the increase in the size is smaller. See the difference here in the ecstasy, but in the midi one, it's called Leopard from a Zera company, you have some increase in the size and some problems of quality, but less. So we came back to our germplasm collection, and just for the beauty of it, we came to the bags of the small bags of the seeds, and you can see that the variation starts already in the seeds. See how different? This is a normal one, and this some kind from Africa or something like this. And when we went to one of the serious diseases, Macrophomina fazolina, we were just astonished to see that in field experiment, we can see difference in resistance. Here you can see the beginning of the lesions when the plants are still alive, but you uprooted from the soil. You can see the points in which the disease started. You can isolate very easily from this spot the macrophomina. Later on it will be rotted, and here completely clean. But if you go and take sections and put it on a petri dish, you can still find the macrophomina, but no disease. So see how beautiful it is. Very resistant, and I think that we are the first in the world to show resistant to macrophomina in watermelon, because nobody looked for it. So this is the macrophomina. In a certain case, in many cases, we have it with fusarium. We talked yesterday about different pathogens together, and here you have example. And here, this is very easy to distinguish because the macrophomina is black and the fusarium is white. But in many cases, we have combination of diseases. Again, here it was separated. Here is from this piece of fruit, macrophomina, and this fusarium. But in certain cases, we can get from the same lesion, we can have macrophomina and fusarium, black and pink. And then we have to be very, very careful to look for each pathogen separately or combined. So 2 weeks later, the susceptible were almost rotten completely, and here still we have it white, but in here there we can see some small lesions, but this was very, very impressive. Very big root system, maybe like squash, but this watermelon, and white without resistance. So there is a possibility to have resistant material for macrophomina. But again, this is only part of the work. We have students that was looking for most of the important diseases, and we have cultivars or germplasm PI numbers that are resistant to many other diseases, and we have the option now to breed watermelon roster. For melon, we are working in 2 areas, in the Arava and in northern Israel, 2 different diseases, macrophomina, monospore ascus. This is the research station in which I am living, is working here. This is one of the new tractors of Neve Yaar. And this is the area, very beautiful area, very nice picture, I took it. Nearby, there is a village of Sde-Yaakov in which we are doing experiment. Here you can see the macroformina. Here you can see grafted plants. And the problem is, in midsummer, the problem is the price of the grafted plant. The grafted plant is about 0.35 new Israeli shekel, 35 agorot, and grafted plant and 2.5 new Israeli shekel. So 7 times expensive than this one. So the question is, if the farmer can pay for it in midsummer, remember the price of the melons is relatively low, and from time to time the disease is not so severe. So the question is if he's going to pay for it. So this is the disease. 2 plants, one is already collapsed, and a different one with the beginning of the lesions of the macroformina. And this is the final stage. Is coming to pick. Most of all of it is wilted. Here we can see 1, 2, 3, 4, 5, 6, 7, 8 melons. He can, if he will pick today, you can from plants that wilted yesterday, you can pick 1, 2, 3, 4, 5. But if he is going to be late in 2 days, they will already soft. And this is the grafted plants. And this very nice picture that shows the mechanism. Very simple, but here is the grafting site. The green one is a part of the squash. The other part is the melon. You can see that this plant was uprooted by the end of the season. And immediately we took pieces from the root, from the lower stem, and from the upper stem. We can see that in the root and the lower stem, the part of the squash, we couldn't find any pathogen. We left it on the bench for a few days and it came out. Maybe some chemicals were there and were not effective after a few days, but you can see that the plant is already diseased. Lot of, again, macroformina and fusarium. Here is fusarium alone. I believe it's not fusarium, I know, it's not believe, it's fusarium solani, it's not fusarium wilt. The main pathogen is macroformina here. So again, the pathogen can penetrate and develop very, very slowly in the rootstock. Once it gets to the xylem, it makes the disease typical macroformina disease lesions. And the story is that the low and slow development of the disease, so the plant is not resistant, but the disease goes very, very slowly. So the question was, what is the increase of the yield? And we tested here 2 cultivars, C4, C6405 and AL, and normally this is non-grafted, MG non-grafted, and 60 is the length by centimeters between one plant to the other one. So we test 60% grafted, 90 centimeters grafted, and 120 centimeters grafted. So lowering the stand, the number of plants per dwelling by 50% to make it cheaper for the growers. And you can see different response of 2 cultivars of melons. This one, you get what you expect. Less plants, less fruit. But here you have compensation like we have in watermelon. In watermelon, we grow one plant in non-grafted plants in 1.5 meters, in grafted in 1 and 2 meters. So we reduce the number of the plants. So again, we have different response of 2 different cultivars to grafting. So from now on, this work was done by, for 3 years, by Nabil Omari and myself. We showed different response of 2 different cultivars to grafting. This El Tamar Research Center, Shimon is working there, but Monospore ascus, this is in Ramat Negev. You can see the Monospore ascus wilt with non-grafted and grafted plants. Again, the same phenomena. You can see that the rootstock part is green, but once the disease goes up, it will cause wilting lesions. But again, it happens from time to time, but very, very slow, very, very late in the growing season. So this is the way that the plant can overcome the disease. We have problems in grafted plants. The grafted plants may, between of poor compatibilities, they can collapse even with no disease, like this. And we investigated this phenomena, and we took soil that was treated with methyl bromide, so no disease was in there, and we grow it in 2 ways. One is sterilized, hanging on the rope, and the other one lying on the ground. And we can see with that with non-grafted melons, we don't see any disease. With melon grafted on melon, we don't see, no disease, no collapse. But in melon grafted on cucurbita, we had no collapse when it was lying on the ground, but we have about 50% collapse when it was hanging on a rope. This problem that may be related to poor compatibility between scion and rootstock. Maybe that it happens when the plant exposed to high temperature, full with fruits, and maybe the water uptake is not good. Maybe the roots are susceptible to high temperature because the temperature in April, May start to rise, and we're looking for rootstocks that will be resistant to this physiological collapse. Here is one rootstock that didn't stand, and here is RS 920 that was very, very good. Unfortunately, in our breeding program, we cannot produce this one because you have to remember that the rootstock are Cucurbita maxima times Cucurbita mutata, and part of them they have incompatibility in the breeding process, and we were trying to do this one, to go back to this one, but it was not successful. So unfortunately, this one we had limited the amount of seeds, and we don't have them anymore. But we are looking at for other combinations. Another phenomena is the increase of yield in grafted plants. Here you can see when you grow it in the greenhouse hanging, you have the first wave fruit in the lower part of the plant, then you have a gap, and then you have another wave. So here in non-grafted you have 2 plants, but look for the quality. The quality is good. The netting is very good. Here is another one that is not netted yet. Then you have a gap, and then you have the second wave in here. What happened in grafted plant? You have your 1, 2, 3, 4, and then you have no gap and continuous growth. But look at the netting; it's quite poor. So you have increase of yield and reduction in the quality. But farmers today know that they have to take off maybe 1, 2, 3, 4, 5. They will take 2 off. They allow this 3 to develop better, but still they can get from 20 to 30% more in yield. Another physiological problem is the susceptibility to soil temperature, high soil temperature. This is in the Arava. This guy is the chief agronomist of Grafted nursery, Roni Cohen. We are collaborating very well with him. And you can see that this soil was treated with methyl bromide. The beds are covered with transparent plastic. It's very important, you'll see for the next. And then the grafted plants are healthy but very small. And the melons are okay. So Amnon is looking at the field, thinking, and he came to the idea what to do. He suspected that the roots of the squash are susceptible to high soil temperature. This was planted in mid-July in the Arava Valley under transparent plastic. What he did in the next year, again, grafted melons on transparent plastic, the same grafted melon on plastic, yellow plastic, that is, it doesn't allow the heat to go in. He lowered the soil temperature in 3 to 4 degrees and allow growing of grafted melons in midsummer by changing the agrotechnology. Very simple and brilliant idea. Compatibility. We did some microscope work. This is the part of the squash. This is the part of the melon. This is the way the zone. Oh, so again, compatibility. This is the melon, cucurbita. And once, it's not a plumber that you screw one type to the other one. You have many small bridges, you can see. And we believe that the rate of the bridges between the sign and the rootstock and the number, the rate of development and the number of them will lead to good or bad compatibility, and it has to be something with plant hormones. Again, the bridges, this was done in Veya with Danny Yoel, a plant anatomist.
See, in our surgery, we call it anastomosis, not bridges.
Yeah. So, but from time to time, when you don't have compatibility and the plant is going to die, it's like this. So they develop advantageous root, and if you plant it too low, it can go to the soil and bypass the grafting. So part of our work was with Dr. Benny Aloni, and he studied the role of auxin, and his suggestion was that the auxin that is produced in the leaves goes down to the roots. When you have non-grafted melon, the amount of the auxin that's produced in the leaves is okay for the roots. But once you have it on squash, maybe it's too high or too low for the roots. So it depends on the root system of the squash you have. If you have not incompatible, the auxin goes to the roots, cause ethylene induction. The ethylene goes and makes free radicals, reactive oxygen species, and then it can damage the roots. Once you have compatible, the auxin goes down, makes ethylene, then make ROS production, free radicals, and then you have antioxidation or anything that is less susceptible to this, and then you have compatibility. And they show it and publish it in a paper, so this can be part of the compatibility between between good and less or bad rootstocks. And here, this one part of this work is susceptibility to different concentration of auxin in a compatible rootstock. Just remind, let's see on this one concentration. Here, 10 by -7, some damages starts. And here you can see that when we treat the rootstock with TIBA, so it's a compound that doesn't allow the auxin to act, we can avoid the problem. Here we have a melon grafted on 62, which is not good. Without TIBA, with TIBA, we avoid the damage. Here we have a compatible, it's almost the same, because the auxin didn't harm this one. And here you have melon grafted on melon, self-grafting. So here is the role, we show the role of the auxin on the roots. And when we treated grafted plants from non-compatible, RS62 is non-compatible control, and we treated with TIBA, we were able to transform bad combination to a good combination. So we proved the role of the auxin, at least for the beginning of the type of compatible and non-compatible. We did some molecular work to show different gene expression between compatible and non-compatible, but it was students that started doing it. She went back to the sequence analysis and they looked for possible role of the genes, but again I think that this should be the next step, maybe for the watermelon to look for the genes that express and to show what happening in the gene expression that causing the damage to the fruit. And this part of our squash collections that we use in our breeding program, and thank you for your attention.